Today we are going to start with kinematics. Kinematics is a sub-branch of mechanics, which is a branch of physics. Kinematics is basically the study of motion, regardless of the cause. We don't study the cause over here. We only study the motion parameters. So, first of all, velocity is in the direction of motion, but acceleration is not necessarily in the direction of motion. The thing that this statement states is that when velocity is towards the right, the motion happening will also be towards the right. If we consider towards the right as positive, then the velocity will be positive. Similarly, velocity and motion will always be in the same direction. Whereas acceleration will not always be in the same direction. Will not always be in the same direction. For an example, if we consider this as the direction of motion, that is the direction of velocity, and if the body is having a negative acceleration, that is the body is retarding, then we say that the directions are opposite. So it's not necessary that acceleration is in the direction of motion, it could be opposite as well. So now what is motion in a straight line? So now what is motion in a straight line? Motion in a straight line is one-dimensional motion. One-dimensional motion. Basically, we only deal with the x-axis, regardless of the other coordinates. It's along the straight line. It will become quite clear as we go ahead. On a curvilinear path, the direction of velocity at any point is tangential to that of path. See, for an example, this is a curvilinear path, and the thing that the statement states is that if we take some point A, the direction of velocity is always tangential to the path, while the direction of acceleration, which is stated ahead, that the direction of acceleration makes an angle theta with the velocity, which means if this is velocity, then this would be the acceleration, which makes an angle theta with the velocity. This will be the acceleration. Now the angle theta over here, if it is less than 90, or you could say it is acute, or when theta is equal to 90, you could say it's perpendicular, or you could say theta is greater than 90, or you could say it's obtuse. We need to keep in mind speed. When theta is less than 90, when it is acute, the speed is increasing. While theta is 90, we see that the speed is constant. While theta is greater than 90, the speed is decreasing. This is important to remember. Moving ahead, if There is a type of question when we are given velocity and we need to find the speed. How do we go about it? Now over here, the velocity of a particle at some instant is given and we need to find the speed. We should always remember that velocity is equal to speed. That is, the magnitude of velocity is equal to speed. This is the relation to be remembered over here. So if v is equals to 3 I cap plus 4 j cap plus 5 k cap meters per second, then if we need to find speed, which is equal to the magnitude of velocity, which is to find the magnitude of a vector, we take the squares. You can relate to the video on vectors where I had explained in depth. And if we simplify this, we go about and get 5 root 2 meters per second, which is the value of speed. Now there are some classifications that we need to keep in mind, which would make our work quite easier. There is something known as one-dimensional motion, which is along a straight line. As I had said, it's also known as 1D motion. In 2 dimension, the body moves in 2 dimensions. That is, it moves in a plane. That it has x and y coordinates. While it is in 3 dimension, it moves through 3D space. In 3D, we know that this is the y-axis, or also known as j cap. This is the x-axis, also known as the I cap, and this is the z-axis, which is also known as the k cap. Now further classifications are made upon uniformly accelerated and non-uniformly accelerated motion. The thing we mean by uniform motion is that the acceleration is equal to 0 and the velocity is constant. When acceleration is constant, we say it's uniformly accelerated. Over here, velocity is not constant. Over here, we need to keep in mind, in uniform motion, acceleration is 0. In uniformly accelerated motion, acceleration is constant, while in non-uniformly accelerated motion, acceleration is variable. Variable in the sense, we need to keep in mind there are 2 methods to solve these questions. The first one is differentiation, and we solve it also by integration. Both of these topics comes under calculus, which will also be taught further. For the sake of uniform motion, we use the equations of motion, which we had studied in class 9th. Now they want 2 examples of 2-dimensional motion. Now examples of 2-dimensional motions we could give is projectile motion and circular motion. Projectile motion is something like this. It has both x and y coordinates. If this is a point we consider, if this is 3 and this is 4, then we will write it as 4, 3. This is the x and the y axis. This is a projectile motion. If we throw something from here, it reaches here and then it reaches here. This topic will be covered ahead. While in the case of circular motion, we consider a circle, or you could say it's known as a circular motion. This is something known as circular motion and projectile motion. This occurs in a plane and has both the x and y coordinates. What is speed, velocity, and acceleration? Speed in the sense, it's the distance covered upon the time it takes to cover that distance, while velocity is the displacement covered upon the time it takes to cover that displacement. In terms of acceleration is the change of velocity upon the time. Generally, all vector quantities are denoted by bars, while the scalar quantities are denoted without bars. Now, what is average speed and average velocity? When we average something, we add all the given distances upon the summation of, otherwise we could write it once for both of them, summation of t1, where d is the distance while t is the time. We could change distance into displacement. Now, what is instantaneous speed and instantaneous velocity? Instantaneous velocity is denoted by ds upon dt, or as we all know, d stands for a small or a tiny change in the displacement and a small and tiny change in the time. That is, we want the rate of change of displacement with respect to time, which gives us the v instantaneous. But if we want to find instantaneous speed is also known as the magnitude of instantaneous velocity. This is an important concept. Instantaneous speed is known as the magnitude of instantaneous velocity. Average and instantaneous acceleration. If we talk about acceleration, we know that acceleration is a vector quantity, and if we want to find average acceleration, the thing we do is that the change in velocity upon the change in time, or we could also write it as v final minus v initial upon delta t. This is what denotes average acceleration. It is defined as the rate of change in velocity, that is delta v, to the time interval delta t, which this change occurs. But instantaneous acceleration is denoted by delta v upon delta t, or we could also write it as dv upon dt. But whenever we write instantaneous acceleration, we cannot write it directly. We need to define the limits. If we write delta v upon delta t, we need to write limit when delta t tends to 0. Otherwise, if you don't want to write when limit delta t tends to 0, we can directly write dv upon dt, or the rate of change of velocity with respect to time. Over here, vf stands for the final velocity, while vi stands for the initial velocity. Now let us solve a question. It is given that in 1 second a particle goes from point A to point B, moving in a semicircle. Find the magnitude of the average velocity. Over here we can, through the diagram we know the radius is 1 meter. So the diameter will be 2r, that is 2 meters. Now the total distance is, we found the total distance. The total displacement we could say, not the distance. Distance would be the correct path traveled or the actual path traveled, but the displacement would be the shortest path, which is the diameter. So if you want to find the magnitude of the average velocity, it would be displacement upon time, or we could directly write it as 2 meter upon 1 second, which would be equal to 2 meters per second. Now the next question states that a table is given and we need to, the time and the speed is given. We need to find the total distance traveled by the particle and its average speed. So first let us see the time interval. When we subtract or we do t2 minus t1, that is 2 minus 0, 5 minus 2, 10 minus 5, we get the difference. And when we multiply time and speed, we get the distance, that is 2 2s are 4 meters, 3 3s are 9 meters, 5 4s are 20 meters, 2 5s are 10 meters, 43 meters. S sum is equals to 43 meters. Now the total is 43 meters. The total time would be equal to 15 seconds. Now if you want to find the average speed, we'll divide 43 and 15 meters upon seconds. 43 upon 15 is equal to 2.87 meters per second. So this is the value of the average speed. Now this question states that the average speed is always equal to the magnitude of average velocity. This statement is wrong. The reason lying is that we know that the magnitude of displacement is always less than or equal to the distance. It cannot be greater than the distance, or it cannot be, it can be equal, it can be less, but it cannot be more than the distance. So it states that average speed is always equal to the magnitude of average velocity. It cannot always be only equal. Average speed can be greater as well. So the above statement is false. When a particle moves with constant velocity, its average velocity is according to this question, when any quantity is constant, then its average velocity, average of that thing, or yes, the average of the thing, instantaneous velocity, etc., all are equal. So the above statement is true. A stone is released from an elevator going up with an acceleration of g by 2. A stone is released from an elevator going up with an acceleration of g by 2. So if we take above as positive, it will be positive acceleration. What is the acceleration of the stone just after release? We need to find the acceleration of the stone. Acceleration of the lift is given. We need to find the acceleration of the stone. Now we know that the stone is released inside a lift. So the gravitational acceleration will be acting, that is minus 9.8 meters per second square. And if we take it from the point of view of a lift, if we take it from the point of view of a lift, acceleration of the lift is in the opposite direction, that is g by 2. So it would, so which is equal to 3g by 2 meters per second square. So with respect to the lift, the acceleration would be 3g by 2. But if we take it from the ground perspective, the point of view, then the acceleration of the gravity would only be observed, which would be 9.8 meters per second square or negative. The clock has its second hand 2.0 centimeter long. Find the average speed and modulus of average velocity of the tip of the second hand in 15 seconds. The length of the second hand is given as 2 centimeters and the time is given as 15 seconds. If we try to draw a clock and in 15 seconds it would cover this much distance. So if 2 centimeter is L, or the second hand reaches to the maximum distance, so we could also take it as the radius. So to find average velocity, we could write total distance upon total time. Now the distance over here is equal to this curved path. This curved path is equal to 2 pi r, that is the circumference of a circle. Now this is 1/4 of the circle, so we'll divide it or multiply it by 1 by 4, which is indirectly dividing it by 4, and then upon the total time, which is 15. Try to cancel, we get 2 ones are 2 twos are, we get pi r upon 2 into 1 upon 15, which is equals to pi r upon 30. If we continue to simplify and insert r as 2, we get pi upon 15. Now we could leave it like this and write centimeter per second. This can also be the answer of average velocity, pi upon 15 centimeter per second. To find the magnitude of average velocity, that is, we need to find the average velocity. Now the total displacement from, if you consider this as A and this as B, it would be the straight line. Now both of these are equal to r, so it would be, by using Pythagoras theorem, square root of r square. square root of r square plus r square upon the total time over here is 15. R square would be equal to 4 plus 4 upon 15 root 8 upon 15. In this question, it is given that is it possible to be accelerating if you're traveling at constant speed? We know that on a curvilinear path, a path which is not straight, even if the speed is constant, the velocity will change. Now, due to the change in velocity, it will be the change in direction as well. So therefore, the acceleration wouldn't be zero. Also, in B, on a it is possible to work with zero acceleration, constant acceleration, and variable acceleration. About constant acceleration, velocity will definitely change, at least due to the change in the direction, because on a curvilinear path, velocity is tangential, which will cause the change in direction. Due to the change in direction, there will be a change in velocity, which will cause acceleration to also occur. So acceleration will be equal to zero. So zero acceleration, it wouldn't be possible. And about constant acceleration, we could take the example of a projectile. In a projectile motion, the path is curved, but acceleration is constant, which is g, which is equal to 9.8 meters per second square. So constant acceleration, yes, it is possible. It is a curvilinear path, and also the acceleration is constant. While if you ask about variable acceleration is always possible because the direction is changing. So variable acceleration is also possible. This question, we need to find the time period, the average speed, and the average velocity. Time period, average speed, and average velocity. We have been given the time as t, and also that the speed of the particle is 1 centimeter per second. So by this given information, we could find, because the speed is constant, the average speed is also constant, so we directly got the answer. Also, average velocity is equal to the total displacement upon the total time. This is the clock, and this is the second hand. Then this would be the 1/4 section of the clock. This would be equal to 90. And this would be the displacement we are looking for. So this should also be equal to r. So it would be equal to r square plus r square, where the value of r is an unknown, but we could write it as r square plus r square will be equal to 2r square upon t by 4. We could cancel this, so we will be remaining with root 2 r upon t by 4. To simplify, we could write it as 4 root 2 r by t. So this is the value of average velocity. But we know that the value of r is 4. So 4 root 2 into 4.0 upon 25.13. We got the value of time by using this simple equation. We know velocity is equals to distance upon time. Velocity is 1, distance 2 pi r, and the time is given as t. So if we transfer, t is equals to 2 into 3.14 into r, that is 4, we would get the value of time as 25.13 seconds. This is how we got the value of time. So by computing all of this, we would get an answer of 0.9 centimeters per second. This is the value of average velocity. Now to find delta v, magnitude of delta v, that is magnitude of velocity. Velocity vector would rotate 90 degrees. So we could directly do v square plus v square minus 2vv cos 90, which would be equal to root 2v, and therefore acceleration would be equal to delta v upon delta t, where we take the magnitude of velocity, root 2 into v upon t by 4. When we equate this, we get 4 root 2 v upon t. This is, if we compute this, we will get 4 root 2 into 1.0 upon t is equal to 25.13. This would give us an answer of 0.23 centimeters per second squared. This is the answer of average acceleration.